Today, we're pulling back the curtain on a type of digital heist that is just mind-blowingly simple. I mean, forget what you see in the movies with all the complex code scrolling down the screen. We're talking about a security flaw where the master key to someone else's private data is just changing a single number in your browser's address bar.
And hey, this isn't just some theory. A security researcher, M7 Arman, found this exact kind of bug out in the wild. See, they got an invitation to a private online group, and being curious, they took a peek at the network request when they clicked Accept. They noticed a simple little ID number in there and thought, what if? With one tiny change, they could waltz right into any private group on the entire website.
And you know what they got for finding this ridiculously simple flaw? The company paid him a cool $2,500, which just goes to show you how incredibly valuable and, let's be real, dangerous these little oversights can be. A single number was literally the key to the whole kingdom.
Okay, so what's so wild about this is just how methodical and easy it was. You see, the attacker, our digital thief, gets invited to Group A. They intercept that acceptance message, find the group ID number, and then just change it to the next number up. And bam! With that one tiny tweak, they're suddenly a full member of a totally separate, totally private group they were never, ever invited to.
So, here's the plan for today. We're going to break down exactly how this happens. We'll start with the website security guard, the digital bouncer. Then, we'll get our hands on the hacker's skeleton key, a vulnerability called IDOR. We'll explore what attackers are really after, look at some absolutely shocking real-world heists, and finally, reveal the one simple rule that could have stopped all of this from happening.
All right, so every secure website you use has a kind of digital bouncer, right? Its job is to stand at the door and protect your data. But here's the thing, this bouncer actually has two very different jobs, and if it messes up just one of them, the whole club comes crashing down.
And this explains it perfectly. First up, you've got authentication. That's basically you showing your ID at the door. You type in your password, the system checks it and goes, yep, okay, I know who you are, you're on the list. But then, and this is the crucial part, comes access control. Once you're inside, this decides where you can go. Just because you're in the building doesn't mean you can get into the VIP lounge, right? All the problems we're talking about happen when the bouncer checks your ID, but then completely forgets to check if you have that VIP wristband.
So, let's talk about that skeleton key. This specific type of vulnerability has a name, and believe me, it is one of the most common and dangerous security flaws on the web today.
It's called an Insecure Direct Object Reference, or IDOR for short. Now, what does that really mean? Well, in plain English, it means the website is just trusting you, the user, way too much. It gives you a direct link to a piece of data, say your own profile, which has an ID number, and then it just fails to ask the most important question, hey, are you actually allowed to see this before handing it over?
So, a normal request looks something like this. You log in, you click on My Profile, and your browser visits a URL that has your unique user ID in it. Let's call it ID number 555. The server sees this, fetches your info, and shows it to you. So far, so good. Everything's working exactly like it's supposed to.
But here comes the heist. An attacker, logged into their own account, just goes up to the address bar and changes that number. They try 556 instead. Now, if the website has an IDOR flaw, the server doesn't even blink. It doesn't stop and ask, wait a minute, you're not user 556. It just blindly grabs the data for user 556 and serves it right up. And just like that, you are staring at someone else's private information.
So, when a hacker finds a vulnerability like this, what's their endgame? What are they trying to do? Well, it usually boils down to one of two things. They're either trying to move sideways to get another user's data, or they're trying to climb straight up the ladder to get total control of the system.
This is something we call privilege escalation. So, horizontal escalation is what we just saw. One regular user peeking into another regular user's account, moving sideways. But vertical escalation, well, that's way more dangerous. That's when a regular user finds a way to access administrator powers, basically climbing the ladder to become a God mode user who can do anything they want.
All right, enough theory. Let's look at some actual digital heists where these exact vulnerabilities were found at some pretty major companies. This stuff happens all the time, and the consequences are huge. First up, a company called Topcoder. A security researcher found an IDR flaw where, simply by changing a user ID in a request, they could pull up the private, personally identifiable information for anybody on the platform. We're talking about the core of your digital identity just sitting there completely exposed.
And the report is just chillingly direct. It leaked everything. Email, full name, internal IDs, all the stuff that was explicitly marked as not public. But there was, wide open to anyone who knew which number to try next.
Next, let's look at the communication platform Mattermost. In this case, a user discovered they could completely bypass channel permissions. So, those company-wide announcement channels that are supposed to be read-only? This flaw meant anyone could post in there, spreading whatever they wanted. The bouncer just wasn't checking for that VIP pass.
And just as the hacker who found it said, they could post in a channel where they simply did not have the privilege to do so. I mean, that's a textbook breakdown of access control. The rules were written down, but they weren't actually being enforced.
Okay, now the stakes get a lot higher. At Palo Alto Software, a user with the lowest possible permission level found an IDOR that let them edit the profile of any other user on their team, including the team admin. This is way beyond just viewing data. This is actively changing it, taking over accounts, and maybe even impersonating your own boss.
And the end result was a complete and total account takeover. An attacker could change the admin's email address to one they controlled, and then, you guessed it, hit the forgot password button to lock the real admin out and seize absolute control.
And for our final and most jaw-dropping heist, a system belonging to the U.S. Department of Defense. Yeah. Here, a researcher found an IDOR so severe that an attacker didn't even need to be logged in. An unauthenticated attacker. That means a complete stranger, no account, no password, could just walk up and take over any user's account.
The report summary says it all. You can change users' passwords and take over their account. That's it. It is the most catastrophic failure of access control imaginable. The digital bouncer wasn't just letting people into the VIP room, he wasn't even at the front door.
So, after hearing about all this chaos, you have to be wondering, how do you actually stop these things from happening? Well, it all boils down to one single golden rule of security, a principle that if they had just followed it, would have stopped every single attack we've talked about.
And this right here shows the simple fix perfectly. The golden rule is never trust user input. On the left, you see the bad code. It gets an order ID and just deletes it, no questions asked. But look at the secure code on the right. It does one extra, absolutely critical step. Before it deletes anything, it checks, does the person making this request actually own the thing they're trying to delete? If the answer is no, the request gets shut down. That's it. That's the whole magic trick.
This one simple check is the difference between a locked fault and a catastrophic data breach. It all comes down to verifying ownership every single time, which kind of leaves us with one final nagging thought. As you go about your day using dozens of different apps and websites, how many of them do you think are just one number change away from exposing everything?